Chapter 11, Thermal Properties of Matter. Today, yes, in this lecture we will see radiation. Yes, we know what is radiation. It is one mode of heat transfer. Okay, yes, there are three modes of heat transfer: conduction, convection and radiation. And yes, in last lecture we have discussed what is radiation. Now we will see in detail. And today's topic is perfect black body and black body radiation. Now, what is meaning of perfect black body? See, if you are given this body, if energy is incident on it, for example, 100 joule energy, and if it absorbs all energy, okay, if it absorbs all energy on it, that is 100 joule. So yes, we can say if a body which absorbs all radiant energy incident on it, it is called perfect black body. Simple. Body which absorbs all radiant energy incident on it is called perfect black body. So it is definition of perfect black body. Okay. If body absorbs all radiant energy incident on it, it is called perfect black body. It is called perfect black body. Okay, it is impossible to have perfect black body in nature. Okay, yes, it is impossible. Lamp black or lamp shoe, it is 98% black body. It means what? It means if you are given lamp shoe, you incident 100 joule energy, it absorbs 98 joule energy. 2% energy is reflected. 2% energy is reflected. Out of 100 joule, it absorbs only 98 joule. Means we can say black. It is 98% black body. And similarly, silver is 2% black body. Yes, silver is 2% of percentage of black body, perfect black body. Clear? So, what is definition of perfect black body? If body absorbs all radiant energy incident on it, it is called perfect black body. In nature, there is no perfect black body. Lamp black, it is 98% black body. Silver, it is 2% black body. Simple. And one most important thing, okay, there is no relation of black body with black color. Yes, there is no relation of black body with black color. Okay, if this object is black, then it is called black body. No. Okay. Now, what is meaning of black body radiation and how we can make perfect black body? So see, I am giving one example. Okay, suppose one cavity is formed like this. Okay, it is reflecting surface. Yes, this one inside it is reflecting surface. Okay, and it is also rough. Cavity is formed like this. Okay, so yes, we are going to see what is called black body radiation and what is meaning of perfect black body. To see this point, here it is like this. Now, why the shape is slotted at this point? Reason is, see, if it is energy incident, energy. You know loss of reflection? Yes, you know laws of reflection. If angle of incidence is 0, then angle of reflection is also 0. So if this surface is like this, then this ray is incident, and on the same path it is reflected. So if we don't want reflection in the same direction, we have to make a slot like this. Clear? So yes, here's one slot like this. So what happens? See, here ray is incident. At this point of incidence, at point of incident, this incident energy, its incident radiation. Okay, what happens? Okay, at this point, it is partly reflected and partly absorbed. Yes, partly reflected and partly absorbed. Yes, so if this incident energy, incident radiation, it contains some energy. At this point, some part of energy is reflected and some part of energy is absorbed. Okay, according to laws of reflection, this ray is reflected in this direction, for example. Okay, again, at this point, it is partly reflected and partly absorbed. From this point, it is reflected, suppose in this direction. So again, at this point, it is partly reflected and partly absorbed. So what happens if the incident radiation having energy liberated, partly absorbed and partly reflected? So suppose I am assuming that here 60 joule is reflected. Then at this point 60 joule is incident. Again from this point partly reflected, partly absorbed. So yes, suppose it is 30 joule reflected. At this point, again out of this 30 joule, partly reflected, partly transmitted, partly reflected, partly absorbed. So suppose it is reflecting in this direction, for example. Okay, so again here let its energy is 10 joule. So see what happens. At each and every point of incidence, energy is partly absorbed and partly reflected. Means after each and every reflection, energy of radiation decreases. Energy of radiation decreases. Suppose after this point, from this point, the radiation is coming out. So almost its energy is very less. For example, I say 1 joule. For example, I say it is 1 joule. And say with respect to this 100 joule, this 1 joule is very small. Means we can say that all incident radiation energy is absorbed in this cavity. Yes, we can say that cavity absorbs all radiant energy incident on it. So therefore it behaves as perfect black body. It behaves as perfect black body. Clear? What is meaning of perfect black body? If it absorbs all radiant energy on it. So yes, this cavity absorbs all energy on it. So it is called perfect black body. Now if this cavity is heated, then what happens? See, this point is important, okay? If this cavity is heated, then it emits radiation. And such radiation emitted from black body, are called black body radiation. Are called black body radiation. Yes, they are called black body radiation. Clear? If this same cavity is heated, then yes, if it is heated, then it emits radiation. Such radiation emitted from black body are called black body radiation. Simple. Okay, so yes, two terms. What is perfect black body and what is black body radiation? Okay, sun. Q and Sun. Its temperature is around 5800 Kelvin. That is too high. Okay, that is too high. And at this temperature, this Sun at this temperature, it emits radiation of all possible frequencies. And therefore we can consider Sun as perfect black body. Yes, we can consider Sun as perfect black body because it emits radiation of all possible frequencies. Yes. Okay, so remember this one point. And see, Sun is not black. So yes, if we can consider Sun as black, perfect black body means color has no relation with this perfect black body. Clear about this point? Okay, so it is perfect black body, and what is perfect black body? Radiation. Okay, now next point. Next point is some definitions actually. Okay, we will see some definitions. So first definition is absorptivity. What is absorptivity? What is absorptivity? Absorptivity is defined as ratio of radiant energy incident. Okay, it is ratio of, see, I will explain you by giving one example. Okay, what is meaning of absorptivity? Suppose it is body, 100 joule energy is incident. Okay, out of this 100 joule energy incident, if it absorbs, it is incident. If it absorbs 60 joule, then what is meaning of absorptivity? Absorptivity is ratio of radiant energy radiant energy absorbed to radiant energy incident on body. So yes, it is definition of absorptivity. It is ratio of radiant energy absorbed to radiant energy incident on body. So yes, absorptivity I can write like this. Okay? Absorptivity is equal to radiant energy absorbed upon radiant energy incident. Absorptivity is defined as a radiant energy absorbed. For example, in this case, radiant energy absorbed is 60 divided by this 100. So it is called 0.6. Or in terms of percentage, it is 0.6 into 100. 0.6 into 100. So it is equal to 60%. So that is called absorptivity. Yes, that is called absorptivity. For perfect black body. For perfect black body, A is equal to 1. Absorptivity is equal to 1. Why? Because what is definition of perfect black body? If 100 joule energy is incident, it absorbs all energy. Means 100 upon 100 is equal to, it is 1. Yes. So remember this one point. For perfect black body, absorptivity A is equal to 1. Absorptivity A is equal to 1. Clear about this? So yes, you have to remember this definition. Okay. Next definition is total emissive power. Okay, what is total emissive power? Total emissive power is defined as what is definition? First of all, I am writing definition, then we will write equation. Okay. Total emissive power is defined as energy radiated per unit area per second at given temperature of object for all possible frequencies of radiation. This definition, okay, it is defined as energy radiated per unit area per unit second at given temperature of object or body for all possible frequencies of radiation. Why it is not for all possible frequencies of radiation? Total emissive power. Why it is named total? See here, sun at 5800 Kelvin. We have discussed in last lecture. K, frequency of radiation depends on energy. Okay, yes, it depends on energy. At this 5800 Kelvin, sun emits radiation of all possible frequencies, every frequency included, So it is called perfect black body. Here, why it is named total emissive power? Because if object radiates all possible frequencies of radiation, that's why it is named total. Okay, what is total emissive power? Now we will write its equation. See, like this. Okay, what is total emissive power? Total emissive power. Okay, what is total emissive power? So total emissive power is equal to, it is defined as energy radiated. So I will write energy radiated divided by per unit area per second, means it is area and second. So yes, you can easily understand the total emissive power is equal to emitted energy per unit area per unit second. How to write this total emissive power? W is equal to energy radiated, means it is E, divided by area A, and here it is T, and here it is T. Clear? So yes, total emissive power, you have to remember. Okay, what is total emissive power? Total emissive power is equal to energy radiated per unit area per unit time. Clear? And yes, you can also write its unit. Okay, what is its unit? Its unit is joule meter raised to minus 2 second minus 1, or joule per second is watt meter raised to minus. So yes, it is definition of total emissive power. Clear? Okay, why it is named total? Because it will emit radiation of all possible frequencies. Okay, now next definitions. Okay, now next definition is emissivity. What is emissivity? Emissivity is defined as ratio of total emissive power of object or any body to total emissive power of perfect black body under the same situation. What is meaning? See, emissivity means what? So see, here it is ratio of total emissive power. It is total emissive power of body to total emissive power of perfect black body under same condition. So it is definition of total emissive power. Okay, so here emissivity. So yes, emissivity is denoted by E. It is total emissive power of body divided by total emissive power of black body under same condition. Simple. For perfect black body, for perfect black body, E is equal to 1. That is emissivity is equal to 1 because total emissive power of black body divided by total emissive power of black body means emissivity is equal to 1. So see, from this we can make one result. For perfect black body, absorptivity is 1, means it absorbs all energy. For perfect black body, emissivity is also equal to 1. So yes, there is one important rule in this chapter that is called Kirchhoff's rule. That is called Kirchhoff's rule. And what is this Kirchhoff's rule? A is equal to E. And now what is meaning of A is equal to E? That is absorptivity is equal to emissivity. Is equal to emissivity. Yes, for object, absorptivity is equal to emissivity. And yes, this point you have to remember. This point you have to remember. Clear about this? Okay? So yes, it is called Kirchhoff's law. It means the surface which is good absorber is also good emitter. Is also good emitter. Simple. Surface which is good absorber is also good emitter. So this point you have to remember. And yes, these all are definitions in case of radiations. You have to remember these all points under radiation. Clear? Now in next lecture we will see most important two laws, that is means displacement law and Stephen-Boltzmann law, and also Newton's law of cooling. That in next lecture, today's lecture, this is it. Remember this all definitions.